Okay, so hi everyone. My name is Gabriela. I am a master's student working with Dr. Tyson Oshner at Oklahoma State University. And today I'll be presenting one of our research projects that talks about how we are upgrading a long-term soil moisture monitoring network through the Oklahoma Hydronet. So first of all, I'd like to briefly explain what is the Hydronet project and what is my role in it. So the Oklahoma Hydronet is a new statewide hydrologic monitoring system. It's led by Oklahoma State in collaboration with state and federal agencies. And it has as the main goal to provide real-time data for early warning systems to help to mitigate drought and flood impacts. And it aims to do it by monitoring and integrating surface water, groundwater, and soil water. And here's where my work comes in. So my role in this project is to help to upgrade the existing soil moisture network that we have in Oklahoma by installing new soil moisture sensors, more technological soil moisture sensors. Which brings us the question, why are we upgrading this network? Why do we want to do it? So first, I have to say that the Oklahoma Mesonet has been providing soil moisture data for the community over 30 years using the CS229 sensors, which is a nice sensor, but as any other old technology, it has some limitations. And one of them is that it only measures the matrix potential, not the volumetric water content of the soil. So we get these matrix potential values and we can estimate the volumetric water content using a soil water retention curve. Also, this network has the deepest measurement depth at 60 centimeters, so it has limited ability to monitor deep root zone storage and drainage. But now, with the new soil moisture sensor, the TERS-12, we are able to measure volumetric water content directly. And also this network will have a new deepest depth at 90 centimeters, which improves our ability to monitor deep soil water observations. So we believe that by doing that, we are updating both the technology and the monitoring strategy in this network. And also we can have more accurate and responsive measurements for statewide monitoring. So with this network upgrade, our research questions are, first, what is the network-wide accuracy of TERS-12 volumetric water content measurements? And second, how do TERS-12 volumetric water content measurements compare to CS229 measurements at 10 and 6 centimeters? So basically, how do the new and old soil moisture sensors measurements compare to each other on the surface and on the subsurface? To answer the questions, here are my materials and methods. First, area study, basically the state of Oklahoma. So the Oklahoma Mesonet has 120 sites across the state with at least one station per county. So we went to all of these stations to install the new soil moisture sensor and also to collect some soil samples. Here about the sensor installation, I have a Mesonet site figure on the top right, and the red line represents where the old soil moisture sensor are installed, and the yellow one is where we install the new soil moisture sensor. So the distance between them is around 2 feet, and we believe that with this setup, we can compare the sensors under the same field condition. Also, we install the sensors at 10, 30, 60, and 90 centimeters deep. And as I said, Oklahoma Mesonet has 120 stations, and we could install the 4 sensors at most of sites, but some of them we couldn't because we had a shallow soil or a restrictive layer, something like that. Okay, so once we were done with our sensor installation, we proceed with our soil sampling. So we use that jackhammer to collect soil cores from the surface down to 95 centimeters. And once we had the soil core, we divide the samples in intervals from 0 to 5, and then every 10 centimeters. So by doing that, we have soil samples that match the sensor installation depths, and we can compare the water content from the soil sample with the water content provided by both sensors. Okay, so moving to my results and discussions. First, we did this sensor comparison, and here on the left, I have the data for the 10 centimeters depth, and on on the right, the data for the 60 centimeters depth. What we could see that for both depths, the sensor agreement was great. They had a strong agreement, which tells us that both sensors are recording similar wetting and drying cycle patterns. And that's great, and that's what we expected. Also, we see a low MAD and bias, which tells us that there is some difference between the sensors, but they are not huge. And also, we expected that since we are upgrading the technology, but as I said, the old sensor was also great. Here, I brought this time series figures from 4 different sites of the Oklahoma Mesonet with 4 different soil textures. And the orange line represents the old soil moisture sensor, and the blue line represents the new one, the TERS 12. And one thing that we can see is that the TERS 12 indicates better and records better the differences in water content. So whenever the water content changes, the TERS 12 is able to detect it, while the CS229 sometimes doesn't, because this is a limitation of this old sensor. It struggles a little bit when the soil is near to the field capacity. So here, as we can see in these figures, the TERS 12 is more sensitive to this water content changes. Okay, so I talked about the sensor behavior, but I didn't answer the question if we really reached our goal to improve this network accuracy by installing the TERS 12. So here are the results for this analysis. What we could see when we compared the volumetric water content that we measured from the soil samples against the volumetric water content provided by the sensors is that for the TERS 12, the new sensor, we have a strong agreement, and the MAD and bias are low, which is great. And when we see the CS229, the old sensor, we see that this agreement is a little bit weaker, and also the error, the MAD and bias increases, which tells us that we reached our goal to improve this network-wide accuracy. So for the conclusions of this project, as I said, this sensor showed strong correlation, but temporal behavior differed at some sites. We don't know why exactly this difference occurred. We thought that it could be about the soil texture, but we couldn't find any clear relationship. So anything that I say would be just speculation. The TERS 12 improved the accuracy and sensitivity in wetting events across sites and depths. And extending measurements down to 90 centimeters deep improves our ability to monitor deeper soil water dynamics, for example, groundwater recharge. And these improvements help in providing better real-time soil moisture data that is available to the public for statewide monitoring and decision-making. For my acknowledgements, I'd like to say thank you to my advisors, Dr. Oshner, Dr. Kruger, to all of the Mesonet team, NOAA for providing us the grant, and for some folks over there, Jerry, Caitlin, Arturo, who traveled with me across Oklahoma installing the sensors. And here I have this QR code that I highly encourage you guys scanning. It will take you to the Hydronet website where you can see soil water, groundwater, and surface water data. And that's what I have for today. Thank you.